Hello, welcome to the new module and now we are going to start the systems and classification of systems. So what is a system? So a system is a mathematical model of a physical process that relates the input, also known as excitation signal, to the output or response signal. So this is some system T and this is the input represented by x of T. Okay, so this is the input and let us say this is system T and it produces another signal y of t. So the system takes input x of t and it produces another signal y of t. So we can also represent this as y of t equal to this t into x of t. It means the system T is an operator which when operates on the signal x of t, it produces another signal y of t. Or we can say it is a mapping from one set to another set. Mapping from one set to another set by a well-defined mathematical rule. Okay, so this is the formal definition of the system. Now let us see the classification of systems. So the first classification is the continuous time and discrete time systems. So a system is said to be continuous time if its input and output are continuous time signals. So if this input is continuous time and the output is also continuous time, then simply this system is known as continuous time system. Now unlike this, if the system's input and output are discrete time signals. So if this is a discrete time signal and output is also discrete time signal, then we call this system as a discrete time system. Okay. Now another classification is system with memory and without memory. And this with memory system is also known as dynamic system, and this without memory system is also known as static systems. So what is a static system or without memory system? So if the output of the system, if output depends only on the present value of input signal, present value of the input signal, then the system is static or memoryless. Memoryless or without memory. Otherwise, it is dynamic system. Okay. So, for example, example of a static system is a resistor. Is a resistor R. Okay. So, if we consider the input as a current, this is R, and if we consider I of t as an input and the voltage across this resistor is an output, then by Ohm's law we can write that V of t is equal to R into I of t. So this is the input output relation of this system, which is a resistor. So here we can see that clearly the output V of t at any time t is depending only on that time instant, okay, not on present and future values of the input. So that's why this is a static system, static or memoryless. Now, as opposed to this, a capacitor is an example of an dynamic system. So capacitor C is an example of a dynamic system or with memory system. So this is a capacitor, and if we pass a current I of t through this capacitor C, then the voltage and current relationship will be V of t equal to 1 over C integration from minus infinity to t I of tau d tau, where I of tau is an input and this is an output. So we can see that at any time t equal to t naught, this voltage will depend on the values of this current from minus infinity up to that time instant t naught. So clearly the value of the output depends on the present and past values of the input. That's why this is an with memory or dynamic system. Now, third classification would be a causal and non-causal. Now, a system is said to be causal if output depends only on the present and past values of input and not on future values of input. Okay, so the system's output should not depend on the future values of input. Then the system is causal, also known as non-anticipatory. This causal also known as non-anticipatory systems, means which could not predict future. So all practical systems are causal. Now, as opposed to this, a system would be non-causal or anticipatory if output depends on future values of input. So this type of systems are known as non-causal systems. Example, their input-output relationship will be y of t will be some x of t plus 1. So at any time instant, the output demands the value of input ahead in time. Means suppose t equal to 1 second, then it requires the value of input at t equal to 1 plus 1, that is 2 seconds. So this is clearly a non-causal system. And suppose y of t is equal to x of t minus 2, then this depends on the past values of input. So this is a causal system. The fourth classification is linear and non-linear. Very important classification. This is linear and non-linear systems. So a system is said to be linear if it satisfies the principle of superposition. So if the input-output relationship of a system satisfies the superposition principle, then it is known as a linear system. Otherwise, it will be a non-linear system. Now, what is the principle of superposition? Note that the superposition means it should satisfy all additivity and homogeneity. It is also known as scaling. Okay, so if both these properties are satisfied, then the principle of superposition is satisfied. Now, what does this mean? So, suppose this is a system. So, this is any system T, and suppose we apply an input x1t and it produces output y1t. And if we give input x2t, then it produces an output y2t. Now, upon adding the input, means if we excite this system by x1t plus x2t, and if the system produces the output y1t plus y2t, means if the inputs are added, then outputs will also be added, then we say that the system is additive. Okay, and the homogeneity principle says that if we apply an input x of t and the system produces an output yt, then if we scale this input by an constant alpha, then the output should also be scaled up by the same constant alpha. Then this system is known as homogeneous system, or this means the system satisfies the property of homogeneity. Okay, now the principle of superposition demands that suppose this is a system T, and upon giving an input x1t produces y1t, and upon giving input x2t it produces y2t. Then if we apply the linear combination of these signals x1t, alpha x1t plus beta x2t, where alpha and beta are some constants, then the system should produce the output alpha y1t plus beta y2t. Then the system will be satisfying the principle of superposition, and thus this is a linear system. Okay, and if this property is not satisfied, then the system will be non-linear system. And the linear systems are very important system because the analysis of these types of systems is easier as compared to non-linear systems. Okay, and so let us move to the next classification, which is time variant and time invariant systems. So consider this system. Now, upon applying the input x of t, we get output y of t as output of this system. Then if we delay the input by some amount t naught, then if the output also gets delayed by the same amount t naught, then the system is said to be time invariant. Okay, so or we can also write it if y of t is this output and say if we delay the input, we get y1t, then this y1t must be equal to y of t minus t naught, that is delayed output. Then this is time invariant, and if this property is not satisfied, then this will be a time variant system. So it means that the output due to the delayed input must be equal to the delayed output. Then the system will be time invariant, otherwise it will be time variant system. Means the behavior of the system should not be changing with the time. The next classification is linear and time invariant. So this is the most important classification, most important type of class of systems. In short, it is known as LTA system. Means it's a system should be both linear plus time invariant. So these are very important systems and their analysis is very easy in compared to the known as dynamic, non-linear and dynamical systems. Okay, so in this core signals and systems, we will be most of the time we will concentrate on our analysis of LTI systems. So the system satisfying both linear and time invariant property are known as LTI systems. Let us move to another classification, which is stable and unstable systems. So a system is said to be bounded input, bounded output, in short known as BIBO stable if for any bounded input the system produces a bounded output. Now the term bounded means can say finite, okay, which does not tends to infinity. So it means this is system T and this is input x of t and this is output y of t. Now if this x of t is bounded, means the mod of xt is less than some number m x which is finite, means less than infinity, then this output must also be less than some number which is less than infinity. Then this system is known as BIBO stable. Okay. Otherwise it will be unstable, means if your input is bounded but the output is not bounded, it is becoming unbounded or tending to infinity with time, then the system is unstable system. And this is the most important concern while designing systems. You should ensure that the system must be a stable system, otherwise it will not be of any practical use. We'll stop here. Thank you.